Hi, this is Lisa. In this video, we're going to talk about functional notation and functions. First, some definitions. A relation is a set of ordered pairs. A function is a special type of relation in which no x values are repeated. In other words, every x value corresponds to a unique y value. The domain is the set of all x values, and the range of a function or a relation is the set of all y values. In example number 1, we're going to determine if the correspondence is a function and give the domain and range. So when I look at this, to determine if it is a function, the first thing I have to do is I have to look at all of my x values. Are my x values unique? I cannot have a repeated x value if it is a function, and those all look unique to me. So I'm going to say yes, that is a function. And then for the domain, I'm going to list in set braces, I'm going to list all of those x values. -3, 0, 1, 3, and 5. And I'm going to close my set with another set bracket. So it's recommended that you put them in order, but it does not matter that much. In MyLabs Plus, you're going to be separating your answers by commas. No spaces, just commas. The range is the set of all y values. So I'm going to underline in blue all of my y values here. Now I notice I have two y values that are the same. I don't have to write it down twice. Any repeated value I only write down once. So I have -2, 7, 9, and -1 for my range. Example number 2. Is my set B a function? Well, again, we're going to start by looking at x values. And right off the bat, there are repeated x values. So I know that it's not a function. When I write my domain, I'm going to write 1, and then the other x values I have are 3, 4, and 5, all separated by commas. My range are the y values. When I look at this, it looks like I only have two unique values there, 10 and 13. So that is my range for that particular function. Oh, did we say it's a function? We said it is not a function because we had two x values that were repeated. Now this is another way to represent a function. You can think of, the input are all the elements in the domain, the output are all the elements in the range. So sometimes we look at functions as sets of points, as graphs, as charts, and other representations as well. So in this one, is it a function, yes or no? And I'm going to say no, because if I look at 2, 2 looks like it's being mapped to both -2 and to 0. 11 is being mapped to -5 or to 5 and to 11. So because of those two reasons, it's not a function. My domain, all of my input values, -1, 2, 5, and 11, and my range, -2, 0, 5, and 11. We want to evaluate a function, or we want to find function values. If you notice in these definitions, f of x defines a function. So our function notation, the function f of the variable x, is given by f of x equals 5x plus 3. Now f of x doesn't mean f times x. That entire symbol is just that. It's one symbol that represents our function. If you look at that, we're asked to find f of -1, f of 1, f of a, and f of a plus 1. So 4 calculations here. Difference between f of x and f of -1, we've replaced x with -1. So in order to find f of -1, that's what I do, is I take wherever I have an x and I replace it with -1. And it oftentimes helps if you wrap your variable in parentheses so you can see exactly where the value goes. And then we're going to simplify this. Order of operations, we multiply first, and then we add. F of negative 1 is negative 2. F of 1, I'm doing the same thing, except this time I'm going to replace x with 1. So 5 parentheses 1 plus 3. 5 times 1 is 5 plus 3 is 8. F of A, same thing. All we're doing is we're replacing x with A. So 5 times A plus 3. Now these are not like terms. I can't add them. That's as far as I can go. That is what f of A is equal to. And our last one here, we have f of A plus 1. So again, remember, we wrapped the variable in parentheses. Here we're going to plug inside parentheses A plus 1 and then add 3. I can distribute. 5a plus 5 times 1 is 5 plus 3, and then I can add my like terms together. So f of a plus 1 is 5a plus 8. And that would be my answer for that. So sometimes you're getting answers that are strictly numeric values, like negative 2 and 8, and sometimes you're getting values that are still expressions. And our next problem here, we're doing the same thing. This time we have a little bit different function. So we're going to do f of negative 2. F of negative 2. And here is a place where your parentheses become really important. Wrap those variables in parentheses. Negative 3 parentheses negative 2. Outside the parenthesis we have the square. It's only the variable that has the parentheses wrapped around it. Plus 5 times parentheses negative 2 minus 1. So this had two places where we had x's. We replaced each x with that same value. Negative 2 squared is 4. So we have negative 3 times 4 plus 5 times negative 2 is negative 10 minus 1. Negative 3 times 4 is negative 12. Plus a negative means minus 10 minus 1. 12 minus 10 is negative 22. Minus 1 is negative 23. And that's my answer for f of negative 2. We're going to do f of 0 next. F of 0. Again, replacing both of those x's with 0. Negative 3 times 0 squared plus 5 times 0 minus 1. Anything times 0 is 0, so we're left with just negative 1. And the last one, we're asked to find f of a. So negative 3 times a squared plus 5 times a minus 1. And I don't need my parentheses here, but I am still going to have an expression with a variable in it. This time the variable has changed to a. And that concludes this video. Have a great day.